2016 past paper. This is what do you call under the trigonometry. B part, C part we have done already during the class. A part we haven't done because we have to finish the trigonometry to do that, all the questions. So this is a good chance to do this as a revision. Please do it. So I can mark somewhere else what's the year. So I can mark somewhere here. This is you can, it's 2016, right? Can you see that one? Hopefully you can see that. Okay, so it's almost exactly 10 minutes, right? Okay, so hope how so one person done, 1, 2, 3. Okay, so many students done. Okay, so it's a time to do the question, right? Okay, so get back to the whiteboard. Okay, guys. All right. So hope you are okay, all of you. Um, so quickly we'll do this question, right? 2016 past paper A level. So we have finished trigonometry fully. Okay. So without any problems, so that's going to be a comprehensive notes that we are having from. Okay. So uh, write down the trigonometry identity for tan alpha plus beta. See, they ask you to write, just write there because they are willing to give the marks to you. Okay, just write it. Tan alpha plus beta, tan alpha plus tan beta over 1 minus tan alpha tan beta. Okay, so they are willing to give marks, so that's why they ask this question. And hence obtain. Oh, see, these kind of questions they are asking. Hence obtain to the 2020 also they are similar to that. Hence obtain tan 2 theta in terms of tan theta and show that. Okay, so this is obviously our question, right? When normally we do this kind of question in our theories, right? When we were doing, right? So tan 2 theta. So you had obtained the tan 2 theta. No? So how to obtain that? Obtain. They say obtain. So I can say alpha equals beta equals theta. Let so say if alpha equals beta equals theta. So you may try to write theta plus theta equals tan 2 theta. So I write like this because I'm going to obtain from here. So it's going to be theta plus theta for me. Here tan theta because tan beta also tan theta. Here 1 minus tan theta into tan theta. Don't put immediately tan square. So next step you can put tan 2 theta equals 2 tan theta over 1 minus tan square theta. Okay, right. So, and show that tan 3 theta. So now it's a tan 3 theta. They talk about tan 3 theta. So what I can do is, okay, tan 3, now we know the tan 2 theta. So you can use the same thing. You can take alpha as a theta, beta as a 2 theta. Okay, so okay, tan theta plus 2 theta. So if I can write here tan 3 theta equals, let's see, this is normal way. So I can substitute there, or I can just write using our things 1 minus tan theta tan 2 theta. Okay. So now instead of tan 2 theta, you have to put this. So it's a big task. You have to substitute that and come. So that's why sometimes you may use T, simple T for tan theta. So, but they didn't encourage that here. So we can substitute and simplify, right? So what I'm going to do is I'm going to substitute here tan theta. I'm going to write the whole tan theta, 2 tan theta over 1 minus tan square theta. You won't see something. Okay, can you see that? Yes. 1 minus tan theta into 2 tan theta over 1 minus tan square theta. Okay. So you are going to simplify that. I simplify here. I erase this one. So eventually I get that tan 3 theta. Okay. So if you take the LCM, so it's going to be tan theta, 1 minus tan square theta, and plus 2 tan theta. So you can write this. Tan 1 minus tan square theta will be cancelled here. So here you're going to write 1 minus tan square theta and minus 2 tan square theta. Okay. Anything else? No. So I erase this one. Okay, guys. So it's going to be tan theta, 2 tan theta, 3 tan theta minus tan cube theta over 1 minus. Oh my goodness. 1 minus 3 tan square theta. This is not chalk, actually, it's a marker how it happened. Maybe from somewhere else. Okay. 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 Oh, read this. Right. So this is that's it. So you will be getting full marks. So now they ask, by substituting theta equal 5 pi by 12 in the last equation, they say, verify that tan 5 pi by 12 is a solution to this. How we can approach that? How we can approach that? By substituting the theta equal 5 pi by 12 in the last equation, verify that tan 5 pi by 12 is a solution to the equation x cubed minus 3x squared minus 3x plus 1 equals 0. So how we can obtain that one? Right, so I'm going to erase this one. Okay, so did they say substituting? Yes, so then we substitute. Okay, so when theta equals 5 pi by 12, then if I substitute here, so tan 3 theta, 3 into 5 pi by 12. Okay, that's going to be 3 tan 5 pi by 12 minus tan cube 5 pi by 12. I substitute because they say substitute. So while you are waiting, substitute. Okay, so 5 pi by 4. What is 5 pi by 4? Pi plus pi by 4 is 5 pi by 4. Third quadrant, tan plus, so tan 5 pi by 4 equals tan pi by 4. So that means 1. So it's going to be 1. So this is going to be 1. So the next step, so you have to repeat it again because one step anyhow you have to write. Tan cubed 5 pi by 12 and divide by 1 minus 3 tan squared 5 pi by 12. Now cross multiply and arrange. So if I cross multiply and arrange and bring the tan cube to this side, so tan cube 5 pi by 12 and minus 3 tan squared 5 pi by 12. Okay, then minus 3 tan 5 pi by 12. Okay, so minus then plus 1 equals 0. Is that so? What do you see that actually? So what do you see in this equation? X cubed minus 3x squared minus 3x plus 1 equals 0. In that equation, this is something like you substituted tan 5 pi by 12 to that equation. Understood? So similar to that. So what I can do is, now I can say, so this then, so this is, so hence, straight away you can write, hence, tan 5 pi by 12 is a root or a solution, what they say, a solution, right? A solution. Because you know that we have learned the quadratic equations, or we have learned the polynomials. We know that if anything something like that, x minus this is a one factor, or then x equals this will it will be a root of this equation, right? So we know that according to that, solution is a solution of, you have to write and see, you have to write and give x cubed minus 3x squared minus 3x plus 1 equals 0. So this form is created. So the how did I get 1? Okay, so I can tell you. I can put an intermediate step. Tan 3, 12 cancel, 5 pi by 4. Tan 5 pi by 4 is tan pi plus pi by 4. Right? Pi plus means third quadrant tan positive. Pi doesn't change the tan to cot tan. So tan pi by 4. So this equals tan pi by 4, that is 1. Okay, so tan pi by 4, that is 1. Is it clear? So I didn't write those steps, but you have to. Understood? Is it clear? How 3 into 5 pi by 12 becomes 1? Because 3 into 5 pi by 12 is 5 pi by 4. 5 pi by 4 is pi plus pi by 4. So it's going to be 1. 10 pi by 4 is going to be 1. So this is a nice question, because just if they talk about the related to polynomials, something like that. Okay, so given further that is something like that, deduce that tan 5 pi by 12 equals 2 plus square root 3. Oh my goodness, that's okay. So we can write it here. So what they say, given further, okay, that's fine. Okay, x cube minus 3x squared minus 3x plus 1 equals x plus 1 into x squared minus 4x plus 1. So it is given to you. So in that case, deduce the tan 5 pi by 12, something like that. Okay, so now how to answer this question? Okay, so that means what they have done, they factorize this. Okay, so we say, so what we can do is, right, since what we can do, you can factorize this now. So for this equation, tan 5 pi by 12 is the solution. We have already shown that here, but we have shown that tan 5 pi by 12 is the solution to this equation. Which equation? This equation. Then the same tan 5 pi by 12 is a solution to this equation also, right? Tan 5 pi by 12 is the solution to this equation also. But we know clearly tan 5 pi by 12 not equal to minus 1. Why? Because tan 5 pi by 12 cannot be equal to minus 1. We know that. Because then minus 1 means tan minus pi by 4 or something other than that. Right? So it is cannot. So what I can say, see, then I can omit this. So definitely I know that tan 5 pi by 12 is going to come from this, going to come from there. So not from here. Okay. So what you can do is, if they say, so you have, okay, then what you can do, so if, right, if x cubed 3x squared minus 3x plus 1 equals 0. Okay, so if it's equals to 0, okay, if it's equals to 0, then x plus 1 into x squared minus 4x plus 1 equal to 0. Yes or no? Yeah, because you factorize this. But tan 5 pi by 12 not equal to minus 1. So the root is not going to come from x plus 1. So you can divide. So you can omit that. So x squared minus 4x plus 1 equal to 0. Okay. Has root tan 5 pi by 12. So you have to explain like that. Or you have to sometime in any other way you have to explain. So now I'm going to solve this. So since I know I can easily using the formula I can solve, or I can make completing squares easy for me. X minus 2 whole thing squared minus 4. Then minus 4 plus 3, this is minus 3. So x is going to be, root 3 plus or minus root 3 and 2 plus or minus root 3. Okay. So again, we have to say, since, so this is, if you take plus, this is whole thing plus. If you take minus, this is going to be, again, this is going to be plus, because root 3 is 1 minus. So which answer you are going to get for tan 5 pi by 12? So that is a very, a challenging one. So we know, obviously we know we are going to get plus, but we have to say why we get plus value, why we don't get minus value for tan 5 pi by 12. Why? Because we know that since 5 pi by 12 greater than pi by 4. Yes or no? Tell me. Is it? Yes or no? 5 pi by 12 should be greater than 5 by 4. Yes or no? Yes, right. Cross multiply and see. 20, 12. 20 always greater than 12. So that implies tan 5 pi by 12 greater than 1. Do you understand? Tan 5 pi by 12 greater than 1. The nice question actually. We see this the easy one. But actually you have to explain this. You have to say this 5 marks. Definitely they will give. Okay, so if you don't explain like that, you won't get full marks. But you may think that okay, I got everything correct. Yes, you got, but actually it's not, because these are the things you have to carefully you have to deal with. So if the question is very easy, don't then carefully you have to do, because some there are instances you have to deal with, right? Okay, straight away you can't write 5 pi by 12 is 2 plus root 3. You can't say because of this, it's show that, because of that, I quickly wrote it. Not like that. You have to justify that. So now justification over. So why? Because we know that 5 pi by 12 greater than pi by 4. Because of the tan 5 pi by 12 greater than tan pi by 4, that is 1. So in this case, now I can say, so tan 5 pi by 12 equals 2 plus root 3. And how nice this question. Very nice. Very nice. It seems to be easy question, but you have to explain through some conditions, right? Okay. Say what I have done. So they have factorized that. So otherwise we have to factorize. So in old past paper, what they will do, they straight away they ask, show that this part. They don't ask something like this. They won't. In old past papers, straight away they will ask like this. But here they guide you, so they know that you have to factorize the cubic one. So cubic equation factorizing, sometimes you may not able to do that. So because of that, they choose this. Okay. So that's a very interesting one. See, in this is a new syllabus. That's right. So you are getting very structured questions. Okay, they help you a lot. Help you a lot. Okay, do like that. Do like this and everything. So if you think about the question past paper just before 2011, so that's a different one. You want to see that? What's the time right now? 27. Okay, so we do one similar questions like this in maybe 2005. Shall we go to that? Okay, so just copy this. I'll complete the 2005 past paper. Okay, so in this question, the examiner helped you to factorize this because he has given that. But think about the children who faced the exam decades ago, right? This is what you are going to get is 2005 past paper right now. So wait for that. You're going to get uh, of course, right. Okay, so slightly I managed to capture it. So hopefully, okay, fine. So guys, okay, so right now we are going to get it, see that how nice that question. So the previous there is a doubt for one say that say can't we take tan 5 pi by 12 as a x? Okay, so you can take tan 5 pi by 12 as a x, but you can't form the quadratic equation in tan 5 pi by 12. Okay, so tan 5 pi by 12 is a constant, no? So in the constant, you can't form the quadratic equation. Understood? So that's why I don't want to use this. So that's why here x is because of that only eventually I got the answer. X is equals tan 5 pi by 12 because already we have proved, because they said Okay, so show that the tan 5 pi by 12 is a solution to this question. Okay, right now. So now consider this. This is going to be 2005 past paper. How nice that. Okay, so you will enjoy this. There is no help, nothing you have to do. Let's see. I'll give another, okay, another 6 minutes to do this. Okay, so enough time. 10 minutes given, right? Enough time. Almost 10 minutes given. Okay, guys. Hi. How was the question? Huh? So you have done 2016 without any problems, but nine, so 11 years ago from 2016, that is 2005 past paper. How was the question? How the syllabus has changed? Now, can you? So you are the witness right now. See, think about there is no clue. Just straight away, right on the target. Just they say, find that, do that, show that, something like that. But here, how nice examiners these days. Let's will do this question. This question says first 2005. It's going to be April actually, but it didn't happen on April. It went to because of the tsunami. It's postponed to maybe June. I don't think yes. Okay, so show that part. First one, 8 cos to the power 4 theta minus 4 cos cube theta minus 8 cos square theta plus 3 cos theta. My goodness, I don't have space to write. So anyhow, cos 4 theta minus cos 3 theta. For every theta, so they say every theta, I put equivalent to. Okay, you have to show that. So I personally advise you to show this, it is better to take the RHS because we know RHS. Because RHS we can expand in terms only the cos theta. But here, if you want to go through the LHS to RHS, then you have to think like that. Oh, here 3 theta is there. Then you have to take about this and this. Here, if you take the minus of 3 theta is there. So, but you have to take this and this and this. So you have to factorize. You have to make it all things squared and something like that. Then only you can go. So that, because of that, I take RHS. So RHS I can do from LHS also, but you're convenient. I am doing it. RHS cos 4 theta minus cos 3 theta. So we close this one. Cos 4 theta is 2 cos square theta minus 1. That is 2 cos square 2 theta minus 1. And minus cos 3 theta, you can expand 4 cos cube theta minus 3 cos theta, isn't it? Yes. So now we have to express this in theta. I think this is also known, so I can use this one. I don't know. 2 cos 2 theta, you can write 2 cos square theta minus 1. Whole thing squared minus. It takes time, but anyway, eventually you can get it. This, if I multiply this, it's something like that. Okay, so what I can do is I can expand this to 4 cos to the power 4 theta minus 4 cos theta plus 1 square. And this is going to be minus 1. Okay. Then minus 4 cos cube theta plus 3 cos theta. So guys, if I multiply by 2, 8 cos to the power 4 theta, is it there? Yeah. So I take this one now, minus 4 cos cube theta. Okay. Then squared, there is no square here. I don't know. I forgot this is squared. I forgot to put it. Now, okay, right. Because if I expand that, anyway, you will identify that. Okay, so then if you multiply this minus 8 cos squared theta, then 2 into 1, 2, 2 minus 1 plus 1. And before that, I put 3 cos theta. 3 cos theta plus 1. So LHS. So you can do like this. Anyhow, you will end up with this kind of LHS. Okay, if you start from the RHS. But if you can start from the LHS also. So in that case, you have to keep this one away, and you have to take care about this one. Okay, right. So then that's it. The first one is shown. Any problem? So if you have anything else, if you want to copy this, I'll give 30 seconds. Okay, guys. So this is the question now, so I can erase it. Okay, guys. So the next one, second one, what they say? He says, carefully read the question. You had to show that cos 4 theta equals cos 3 theta if 7 theta is an integer multiple of 2 pi. Oh my goodness. Oh, that's if 7 theta is an integer multiple of 2 pi. What do you mean by integer multiple? Oh, I got it. So we start from that 7 theta is integer multiple of 2 pi, means I multiply that 2 pi by n. Okay. So I put n because you will enjoy that if I put n. And I say n belongs to z. Have you noticed this kind of things anywhere? Yes. General solution. At the end, we use this, if anything, something like that, we divide by 7 later. But before that, we put n belongs to z. So this is reverse. That's why they say what they say. They say the last part. If 7 theta, that's a condition. If 7 theta is an integer multiple of 2 pi, so then I write that in a mathematical form. 7 theta equals 2n pi, n belongs to z, integer. Okay. So now I have to show that cos 4 theta is cos 3 theta. That's easy, right? Because I know that cos, I can write this is 4 theta plus 3 theta, 2n pi. 4 theta equals 2n pi minus 3 theta. Now you take the cost both sides. Take the cost both sides. Okay, so this is the easiest one. You can solve also. By solving that, you can show that 7 theta is integer multiple. That is also possible, but this is also nice. So if I take cos 4 theta, then cos 2n pi minus 3. So cos 4 theta is going to be cos 2n by fourth quadrant, then cos 3 theta. That's it. So you can go from here also. That's not a problem. Cos 4 theta equals cos 3 theta. You can write 4 theta equals 2n pi plus or minus 3 theta. Then 3 theta is okay. So integer multiple and something like that. Okay. Okay, this is the reverse. So they ask if 7 theta is an integer multiple of this, then you can show that. Okay, that's okay. You can go from here also by solving general solution, finding the general solution. If you do that, you will write to 4 theta equals 2n pi plus or minus 3 theta. If you take the plus, 4 theta equals plus means theta equals 2 n 1 pi. If you take minus, 7 theta equals 2 n 2 pi. So they talk about this one. So there is a condition. You are going to have that one also, but that is not shown in the question. So then you have to follow this method. This is okay. So now we have come to the last part of this question. So we have come to the last part of the question. So question says, suddenly they asked without anything. Suddenly he asked, deduce that cos 2 pi by 7 plus cos 4 pi by 7 plus cos 6 pi by 7 equals minus half. My goodness. How to do this one? Okay, so with this question, I'm going to conclude the class right now, but it's actually because of nothing. Okay, I'm going to conclude the class right now by doing this, but hereafter you can do 2006 past paper. It continues like that. 2006 past paper, then come back to 2018 past paper. Okay, so go back to 85 past, I think so. So something like that, because there's a chain, right? Okay, so there's a chain. There's a chain. Okay, so I can do that, but anyhow, I have to have the dinner. Still, I didn't actually. Okay, so uh, resist to sleep. I have tomorrow morning. I'm having the morning class also. That's the problem. I have to get away. Okay, anyhow, so we'll finish it. Okay, right. So what I can do is oh, to reduce that. How to reduce this? I haven't heard about this 2 pi by 7, 4 pi by even 2 pi by 7. I may think about somewhere here. If I divide by 7, but I don't know what is 4 pi by 7 and 6 pi by 7. How to get those numbers, those values inside the cost, and you have to add everything. So how it's possible? So these are the questions I'm thinking of. So there is, but I know this because because if I'm facing the exam in the final exam paper, so I should have done more questions in the past papers. So I know that how to deal these kind of questions. So then that's why we are learning, right? Okay, it's through the past papers. So that's why the revision class is very, very, very important, because most of the time we don't learn these kind of things in our theory class. Theory class very focus on the theory and finishing the theory. Related to that, we do see here and there the past paper also. Okay, so I'm the only one doing the past paper related to that. So otherwise, just we can finish this, the theory, and we can do all the past papers in the paper class normally. But here we can't do all the past papers in the theory class now. So then revision is needed, and revision is needed because of you can connect everything, all the past papers quickly, right? Anyhow, come back to this. So in this case, what we can do is I'm going to solve this. Okay, I know that this is the equation of cos 4 theta equal cos 3 theta, and an equation. So the solutions of this equation. What are the solutions of this equation? What do you think about that? So solutions of these equations must be here. Okay, is it clear? Right. So see, there are 4 theta. 4 theta means you have to have 4 solutions. 4 theta is the highest one compared to 3 theta. So you have to have 4 solutions. Okay, so among the 4 solutions, you can find at least 3 solutions from here. Here, why? Because the theta 2n pi by 7. So the first solution, theta can be by putting n equals, putting n equals 0. That's also possible, right? N equals 0. So theta 0. So one solution. Is it possible? Yes, put there. Cos naught 1. Cos naught again 1. Yes, correct. So theta equals 0 can be one solution. Other one, put 1 for n. 2 pi by 7 can be solution. Yes. Other one, 4 pi by 7 by 2. By putting 2 for n can be. By putting 3, 6 pi by 7. Now, now only I got it. Oh, so now I can see these values here by putting n equals 0, this one and this one. So I stopped with the 4 values. Why? 4 distinct values. These are the distinct values. This is not equal to this. This is not equal to this. This is not equal to this. Okay, these are the distinct values. So if you put 5 for n, what do you get? 10 pi by 7. If you put that, sorry, 4, just 8 pi by 7. Okay, if you put 4 for n, you get 8 pi by 7. But 8 pi by 7, almost you can think by, okay, is it 8 for 8 pi by 7? So how you can think about 8 pi by 7? It's you can think, say, pi minus pi plus pi by 7, isn't it? If you put that n equals 4, 8 pi by 7, you can write pi plus uh, 5 by 7 or something like that. But why I am not able to put n equals 4, not 4, 4, because I know that this equation has 4 solutions, because 4 theta, that is our aim. If it's 2 theta and 3 theta, then 3. Okay, so if it's 2 theta and theta, then 2, right? So another word, I can say another word. Have you seen this cos 4 theta and cos 3 theta uh, somewhere else? Yes, the first one show that 8 cos to the power 4 theta, that equals cos 4 theta minus cos 3 theta. So if cos 4 theta equals cos 3 theta, that quartic, that is to the power 4 equation going to be 0. Okay, so from there only we have to get this. Understood? So there are 4 solutions. Suitable 4 solutions are there. So right. So now what you can do, how to answer this question? So since cos 4 theta is cos 3 theta, theta equals 2n over 7, n belongs to z. So possible values of theta, right? Right now, possi uh, possible values of theta. Values of theta: 0, 2 pi by 7, 4 pi by 7, 6 pi by 7. Okay, these are the possible values. So since right now, since cos 4 theta equals cos 3 theta, then that 8 cos 4 theta, 8 cos to the power 4 theta, previous one, the first one we have shown that, write down that that's going to be 0. Is it clear? Plus 3 cos theta plus 1, that is going to be cos 3 theta, cos 4 theta minus cos 3 theta, no? So if cos 4 theta equals cos 3 theta, this is going to be 0. So now tell me, so here from the cos 4 theta equals cos 3 theta, what are the values you are having for theta? These are the values. Then tell me, what are the solution for this equation? Cos of this value, that means cos 0, cos 2 pi by 7, cos 4 pi by 7, cos 6 pi by 7 are roots of above equation. Yes or no? Yes or no? Because that equation, this equation in terms of cos theta. So here only theta. So if this is equal to 0, so cos of these angles going to be the solution of this equation. Understood? Now, okay. So what we can do now? So what you can do is, there are many methods. You can find it. There are many methods. So hereafter you have to do summation of root, quadratic equation. Likewise, quadratic equation, summation of root, you have to write. So how to do that once? Because this is going to be quartic ones, x to the power 4. So how to do that one? There are many methods hereafter. So one method, there are 1, no, 2, 3 methods. So I'm thinking in which method I am going to explain to you. So some students, what they will do, they found that cos naught is the solution, no one solution. That means 1 is the solution to this. So they can take the cos theta minus 1 as a factor. Then you can factorize other one, and you will get the cubic equation. Then for cubic equation, addition means these three. These three roots are those these three are the roots of that cubic equation. If you take the cos theta minus 1 as a factor, you will get the cubic equation, right? Other side, that as a quotient, cubic one. So that roots of that cubic equation will be this and this and this. For that, if you write summation of root, this is the answer. But summation of roots straight away you are not able to write. But anyhow, if you write, they will give the mark, no problem. Otherwise, you have to do as a polynomial. Polynomial, then x minus cos, then x like that, cos theta minus this into cos theta minus this into cos theta minus this, equate this cos squared or cos cube or something like that. Okay, so there is a one method like that. Or straight away you can write for quadratic, the summation of root also acceptable. That is straight away you can write. Okay, so that is also acceptable. So whatever things you can do. So shall I erase this? Okay, so forget about these things. Now quickly we go back to the polynomial. Think about this. If ax to the power 4 plus bx cube plus cx squared plus dx plus e equivalent to, say, okay, I divide by a, everything. Okay, so I divide by 8. I divide everything by 8. So it's going to be x minus alpha, x minus beta, x minus gamma, x minus delta. See, okay, think about this. There are 4 solutions. There are 4 solutions to this equation, right? Think about it. There are 4 solutions. Then what is alpha plus beta plus gamma plus delta? How do you get that? How do you get alpha plus beta plus gamma plus delta? By equating x cube, will you be able to get that one? Say here, b over a. Here, how to get the x cube? Oh my goodness, how to get the x cube? So x cube is this into this into this into this number. So x minus delta. Oh yeah. And this into this into this into then this number. Okay. I can say this into this into this into this number minus gamma. All right. Then this into this into this into this minus beta and minus alpha. So you know alpha plus beta plus gamma plus delta is going to be minus b over it. Same as quadratic equations. Quadratic equation alpha plus beta minus b over it. To the power for that quartic equation, we call this a quartic equation. Again, alpha plus beta plus gamma equals minus b over it. But cubic equation other way around. Okay, so you don't put minus for cubic equation. So you can observe that one. Okay, cubic equation. So hopefully this is correct, right? Okay. So straight away also you can use this one. So method 1, write down method 1. After this, method 1, write down method 1. Method 1, summation of roots. See, cos naught plus cos 2 pi by 7 plus cos 4 pi by 7 plus cos 6 pi by 7. That's going to be minus b over a. So it's going to be 4 by 8. That is half. Okay, so what is this? This guy is 1, no? So subtract that. So cos 2 pi by 7, cos 4 pi by 7, cos 6 pi by 7 is going to be, this is 1, no? 1 minus half minus 1 minus half. That is the answer. That is the answer. This is method 1. If you do like that, 100% they will give marks. No problem. Don't worry about that one. Okay. So we go for the, I erase this one. Method 2 also. Quickly we do the method 2. Okay. So method 2. Method 2 is, since cos naught is the solution to this equation, that is cos naught is 1, no, cos theta minus 1 must be the factor of this equation. So I can factorize this. So I take cos theta minus 1 and 8 cos cube theta. So you can write using the long division or anything, whatever thing you can write. This is, so say this is 2005 past paper. I can remember, I can recall one thing. The same 2005 past paper remainder theorem question also you see similar cubic one. So sometimes they may say x minus 1 is a factor or something like that. You have to take it out. You have to write the quotient using the cubic one. Okay, so in 2005, the same paper, remainder theorem, please do that one. So, right, so see, it's one of these kind of things, I don't know. So I'm just using the synthetic division. Synthetic division, yeah, synthetic division is not in our syllabus, but anyway, if you can use, no problem. I'm going to write like that. 8 cos cube, there is no 3 plus 4 cos squared theta and 1 cos squared theta minus 4 cos theta, and so 1 4 minus 1 equals 0. So you can factorize this. I erase this. So since cos theta not equal to 1, because we are not interested in that, because they didn't say. Okay, so you can write cos theta not equal to 1, or you can write just say cos 2 pi by 7 comma, cos 4 pi by 7, comma, 6 pi by 7 are roots of this equation, not this. So 8 cos cube theta plus 4 cos square theta minus 4 cos theta minus 1 equals 0. Now hereafter you can write the summation of root. Summation of root for the cubic equation, not minus b over a, it's just b over a. So summation of root, that is cos 2 pi by 7 plus cos 4 pi by 7 plus cos 6 pi by 7, that equals, yes, it's a minus b. Oh, by the way, I forgot about that one. Let's see. I forgot about, did I say that it's not minus? Let's see, check. I made a mistake, check. We'll check that. It's going to be plus. Okay, check that. X cube, ax cube plus bx squared plus cx plus d. Ax cube, bx squared plus cx plus d equivalent to. So divide everything by a, x minus alpha, x minus beta, x minus gamma. Oh, this is the summation of root. Okay. Oh my God, sorry. This is summation of. I thought it's a product of the root. I think so. Product of the root, they change, right? So if you equate the x squared, that is b over a, it's going to be here. X squared means this into this and number. So that is minus gamma, then minus beta, minus alpha. So alpha plus beta plus gamma, again minus b over a. So again minus b over a. So summation of root. So normally we think about summation of root. Other thing will be a product of the root, right? So keep it in your mind. This summation of root is minus b over a. It doesn't change, right? Minus b over a doesn't change. But product of the root will change. Okay, so for this product of the root is alpha beta gamma, this minus alpha beta gamma minus d over a. See, alpha beta gamma minus bd over a, because if you multiply this you will get odd number of, so minus still there. So in quadratic one you will get even number, so alpha beta gamma delta, then there is no minus d over a. So that is for the product. Okay, so right now same thing, minus b over a, that is minus half. So that's the answer. Understood, guys? Please. Normally, if you think about alpha plus beta, at the same time we think about alpha beta, right? So this is not like that. Alpha plus beta plus gamma, alpha plus beta plus gamma plus delta. That is quadratic first one. Second one is cubic. Third one is quartic. So for anything, the summation of root is minus b over a, because we know that. We proved also, though, that's right. Okay, is it clear? So summation of root is right, but product of the root change. For the even values, alpha beta gamma delta, that is just d over a. Here d over a. For quadratic one, c over a. Cubic one minus. Okay, right. Is it clear? Okay, so I'm going to conclude the class right now. So it's the time up. Oh my goodness, 1 hour. I thought I can finish with 40 minutes today class, but it lasts to the 1 hour. So no homeworks. I'm not going to put you in trouble. So we will continue, but at least 2 questions, 2 past papers, very well enough, right? Best. Okay, guys, you have connection also. I have told you something else in not only the trigonometry, but I related to the remainder theorem also. If you have the paper, maybe Pesuru or something, you can just read and see. You can do the remainder theorem in 2005 past paper. See, the same thing, similar thing. So if you do in this method only, so if you are doing in the method one, no problem. It's just, minus b over a. If you are doing method two, then you have to have that, factor, and you have to factorize this. Okay, so guys, bye. See you. Good night.